Hello students, now we are back with the remaining questions of exercise 3E. So I shall be doing now question number 4. Okay, in question number 4 we have there is a particle of mass 25 kg has two forces acting on it. One 20 newtons and the other of 35 newton. Now here is a particle and its mass is 25 kg. So I'll be showing its weight downwards, that is 250 newtons. Okay, now we're given that there is a force of 20 newtons. Here is a dotted horizontal line and there is an angle of 60 degrees. Okay, and this is the force of 20 newtons and this angle is given here as 60 degrees, and then there is another force of 35 newtons. Here is the force of 35 newtons and this is acting at an angle of 10 degrees. You can check this in your notebook. Okay, this is the fourth question. We will find the magnitude and direction of the resulting acceleration. Okay, now the thing is that we have to find the acceleration. So I will not be considering this weight over here for the acceleration, okay, because that would be used for F equal to ma thing. Okay, so right now we shall only be finding because both the forces are like acting towards the right side. So obviously we have to see that where is going to be the resultant acting. Okay, so the direction and the magnitude. So I shall be resolving it like this: force over here, this one is 20 sine 60 and this one is 20. I wish if I had different colors markers. Okay, I can have this. I have this black one. Okay, and this one is going to be resolved like this. This is 35 cos 10 and this is 35 sine 10. Okay, so we have to find the resultant of these two forces acting on this object which has a mass of 25 kg. So right now the Rx is going to be 20 cos 60 plus 35 cos 10. Okay, and then the Ry will be you can see this one 20 sine 60 and this one is like downwards, this is minus 35 sine 10. Okay, now some of you might be confused that why did I like remove that weight from here, like that I initially drew over here. Now just imagine that here is this calculator. Let's suppose this is like it has a mass of 25 kg and we are pulling this, like this is one force in this direction and this is the other force in this direction. And can you imagine that which direction would the weight be directed right now? That is obviously directed downwards. Okay, so this means that the weight has no role in its into the resultant of these two forces which are pulling this calculator right now. Okay, so that is why yeah, later on in the next chapter we shall where we'll have to determine the frictional force, the resisting force. So there we shall be needing the weight to determine the R. Okay, so right now this weight is not required because the weight and these two forces, they are not coplanar forces. Okay, because this calculator has to move on this table, therefore we need to know the resultant of these two forces. Okay, So we have this Rx 44.468 and this is the Ry. Now let us find the R. Okay, the resultant of these two forces. So that is the this tube light. Mukarrab, can you switch off this light, please? This is square root of Rx square. Thank you. And then this is your Ry square. Okay, so I have used a calculator to find this R. Now this R will be, I mean, the result, this R is not the normal contact force. This is the resultant of these two forces acting on this block over here. Okay, so now we are going to use the F equal to ma to determine the acceleration of this object. Right now we are not concerned about the direction. Yeah, oh, he has asked for the direction as well. Okay, so let me first of all find the acceleration. Okay, so F equal to ma, that is 45.867. Its mass was 25. So from here you get the acceleration. Okay, and then the direction of the acceleration, for that I'll be using finding this tan theta is tan inverse of this Ry over Rx. The direction of the acceleration is obviously the direction of the resultant of these two forces. And again you can see that the Rx is positive, the Ry is positive. So this would be directed towards the first quadrant direction. Okay, so that would be, you can find this angle and then you can check your answer. Okay, next we are on to the sixth question. It's a bit different question. It says three coplanar forces act on a particle as shown in the diagram. Force F has a component of minus 30 in the x direction and minus 40 in the y direction. Find the value of alpha. So you see he has given us this force F's x component and the y component. Okay, so this is, I'll be mentioning here, this here as 30 and this one here as 40. You can understand this clearly, that why this was given as minus 30. Obviously this is the x direction, so this is going to be to the negative x axis and this is the negative y axis. That is why this was given as minus 30 and this was given as minus 40. So he's asking for the value of alpha over here. Okay, so this is simply alpha would be tan inverse of this 40 over 30. Okay, this alpha would be, so this alpha is 53.1 degrees. Okay, so I can mention it here. This is 53.1 degrees. You can find the value of F as well. F would be 30 square plus 40 square. So this is a typical right angle triangle. So this would be 50. So he didn't ask about this F. So if he had asked about this F, so that was definitely 50 newtons. Okay. Now the next part, it says find the magnitude and direction of the resultant of the three forces. Okay. Now we have to find the resultant of these three forces. So we don't need to resolve this F now. This is already resolved. This is a vertical force of 40 newtons, and this one I would rather like to resolve this. This is going to be 30 cos 30 and this one is 30 sin 30. Okay, now let's find the Rx first of all. The Rx will be, now this 30 cos 30 and then this minus 30, that is the resultant's horizontal component, x component. Okay, and then the Ry. Now we have one force upward which is 40 and minus, there are two forces. One is this 30 sin 30 and then plus this one is also downwards, which is 40 newtons here, this one 40. So you get this Rx and this Ry. Okay, I have used the calculator to find these values of Rx and Ry. You can see that they are both negative. So when they are both negative, so that means the resultant is basically directed towards the third quadrant. Okay, like if I'm stretching my arms, Like, you know, this is the negative x-axis and negative y-axis. If I sketch this roughly, so this would look like this, like, you know, just a tentative scale. This is -4 and then there is -5, okay? So it is always a good idea to have a rough sketch of the resultant. Don't try to draw it over here, so your diagram will be very confusing. So this is -4.0192 and this one is -15. Oh, I should have drawn this a bit longer because I have to maintain that scale. This is -15. So once again we shall find this basic angle, okay? I'm just going to erase this. Okay, so the basic angle is going to be theta is tan inverse of -15 over -4.0192. So this is 75.0 degrees, okay? So we have to, when we write our answer, we can say that this is 75 degrees anti-clockwise from the negative x-axis, okay? And the magnitude of this r would be the square root of this rx, which is, I'm not writing the minus here because when you take the square, obviously the minus would be turned into the positive, okay? So this will give you the resultant's magnitude over here, and this is the direction, okay, of the resultant. This is anti-clockwise from negative x-axis. Okay guys, now we move to the 7th question. That will be the last question of this video, okay? Now there is a problem with this statement over here. The question says 3 coplanar forces act on a particle, okay? But there are 4 coplanar forces. So this is the printing error over here, okay? So we have to show that the x component and the y component of the resultant are equal. So basically we have to show that for these 4 forces, 4 coplanar forces, the Rx and the Ry, they are both equal to each other, okay? So I shall be finding the Rx and Ry, okay? So this is the area for the Rx and I'll keep this area for the Ry. Okay, first of all, there is no need to resolve this force. This is already vertical. I'll be resolving this force first of all, and this would be resolved like this is going to be 60. Now guys, you must be very good at these components thing, okay? This is 60 sine 30, okay? And now for this, now there is a lot of overlapping, so let's see if this marker really works. For this 20 newtons, basically the shops are closed, so I am not able to get a marker for you. अब ये पढ़े ये सही हो गया ये वाला marker, okay? Now this is going to be 20 cos 60, and this component would be 20 sine 60. So please see that we have to see that what is the angle of this force with this x-axis. So this is 30 plus 30, that is 60 degrees. That is, I'm keeping this as 20 cos 60 and this is 20 sine 60, okay? And when I resolve this force over here, so this is going to be resolved like this. So this is your 40 cos 60 and this is 40 sine 60. Now the question says that you're not allowed to use the calculator in this for this question. The reason is these angles. You must know the exact values of the sine and cos of the 60 degree and the 30 degrees. Okay, so that is why there is a sign that we can't use the calculator over here. Okay. So there's no problem. I believe you guys know that sine 30 is half and cos 30. I should mention here, like, you know, your sine 30 is same as cos 60 and they are both equal to half. And your sine 60 is same as your cos 30, which is under root 3 over 2. Okay, so the Rx is going to be, how many horizontal components we have? Obviously there are 3 inclined forces, so there are 3 horizontal components. So first of all, I'll be writing this one, 40 cos 60. So this is 40 cos 60. Then I'll be putting a minus with these two because these are in the opposite direction to this 40 cos 60. So I'm using, like, this is minus 20 cos 60 and then minus 60 cos 30. So I have taken this force, and this force. Okay, so now this Rx is going to be, now cos 60 we know that is half, so this is going to be 20, and again cos 60 is half, this is going to be 10, and cos 30 is under root 3 over 2, so this is minus 30 under root 3. So trying to do this without the calculator. That is what your question says. Okay, now we come towards the vertical component. Here is the Ry. Now Ry, first of all, I have this 40, okay, and then there are 3 downward forces, okay. One is 40 sine 60, then I have this 20 sine 60. I'll put a minus with this because this is a downward force, and then I have this 60 sine 30, and this is going to be minus 60 sine 30. Okay, let's hope like we get the same answer here. This is going to be 40 minus, now this sine 60 is under root 3 over 2, so this is minus 20 under root 3. Again sine 60 is under root 3 over 2, this is minus 10 under root 3. Okay, and this sine 30 is half, so this is going to be minus 30. So we have 10 minus 30 under root 3. So you have seen that both the Rx and the Ry, they are same. This is the Ry and this is the Rx. Okay guys, you have seen that they are both, like, you know, the Rx and Ry are same, and they are both negative as well. You can use your calculator to determine, like, you know, that this is minus 30 times it is more than 1, so this is going to be like negative. This is also the same negative value. So can you guess the direction when both Ry and Rx are same? So do you have any idea of the direction, the angle? Yeah, if you imagine the tan inverse of 1, obviously Ry and Rx are equal, so Ry over Rx is going to be 1. So it is going to be something related to 45 degrees. And when both of them are negative, so that means it's going to be towards the third quadrant. And if I tell you exactly, the angle would be 225 degrees taken from the first quadrant's x-axis. Okay, so that's it from the exercise 3E. This ends our chapter. Okay, inshallah, in my next video, I'll be showing the solutions from some of the past paper questions. Okay, thank you very much.